Okay, I'm going to show you how to factor a trinomial where the leading coefficient is not 1, so where a is greater than 1. It's kind of a combination of normal factoring and how we would do factor by grouping. What we're going to do is actually create 4 terms here so we can factor by grouping. First, you always want to check, do I have a common monomial factor? Well, 8, 2, and 3 do not have a common factor, and I do not have a variable here. So unfortunately, I've got to deal with this leading coefficient of 8. So here's how I do it. I actually write down the first term and the last term. And I don't do anything with those yet. What I'm going to do is I'm going to take this positive 2x and split it into 2 terms. Okay. The way I'm going to decide on what 2 terms these are going to be is I'm going to multiply my a and my c, the 8 and the negative 3. I get negative 24. So I know that I'm looking for a product of 24. I want the sum to be positive 2. So if the product is negative 24, I have one of them is going to be negative and one of them is going to be positive. And it does not matter the order. In the end, you'll get the same answer. Okay, the products, the factors of 24, I've got 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 is not a factor, and then 6 I'm back to here. So I've got all my factors. Now remember, if the product is negative, when I'm finding the sum here, I'm really looking for these numbers to be the difference to be positive 2. So the difference here is 23, 10, 5, oh good, I've got one here. So the difference of these two is 2, so it's going to be 4 and 6. Now if the middle term is positive, my larger one is going to be positive. So it's going to be plus 6x and negative 4x. So again, look, negative 4x plus 6 is 2x. So all I've essentially done here is split this term. So I'm going like backwards from simplifying. Okay, now I'm going to factor by grouping. So I'm going to take my first 2 terms and find a common factor, and then I'll take my second 2 terms and find a common factor. Okay, I can divide both of these by 4x. Okay, 8x squared divided by 4x is 2x. If I multiply these back out, I get 8x squared. Negative 4x divided by 4x is negative 1. Don't forget to put that 1. Sometimes people leave it off. So 4x times negative 1 is negative 4x. Okay, let's look at the second, or the third and fourth terms here. 6x and negative 3, I can divide them both by 2. I don't have a variable here, so I can only take out a 2. I want it to be the same. Oh, I'm sorry, I'm going to take out a 3, because see, I want it to be the same as this. And that's always a way to check your math, too. I caught my mistake, because if I divide this by 2, I'd get 3, and that's not what I want. Okay, divide them both by 3. Duh. Okay. And I want to take out a positive 3, because when I multiply it back out, I want to get 2x. So 6x divided by 3 is 2x. Negative 3 divided by 3 is negative 1. And I'm happy to see that my 2 binomials are the same. So remember, by factor by grouping, I'm going to take this first term and the second term, and I'm going to factor out the binomial. So 2x minus 1 comes out. It leaves me with 4x, and in this term, plus 3. Okay, if I multiply this by 4x, I get that. If I multiply this by 3, I get that. Okay, I'm going to check with the calculator. I also want to make sure that I didn't miss anything, that I factored all the way. There's nothing else I can do. There's no common monomial factors in either one of these. They're not special cases of binomials. So if these match up, I'm feeling pretty good about my answer. Okay, so I'm going to store a nasty number in for x. I'm going to use pi. I'm going to put in my original expression, 8x squared plus 2x minus 3. Find out what it is. Go ahead and put in the answer that I came up with. So 2x minus 1 and then the sum of 4x and 3. Okay, if these are equivalent, then I feel pretty good about my answer, and they are. So I've simplified it correctly, and hopefully I've simplified completely.